is a review of the Edgenuity lesson, Dividing Radicals. To start off, I'm actually going to jump down here to example 2, and then we'll go back and do example 1. Example 2 says, what should we multiply by to rationalize the denominator? So we don't actually have to simplify, we're just figuring out what would we multiply by. So the denominator here is 5 times the square root of 7. So the issue is we can't have a radical in the denominator. So what you do is you just multiply the top and bottom by whatever that radical is. So we have root 7, so we would multiply the top and bottom by root 7. This next one, though, we have 9 plus root 13. Whenever you have something being added or subtracted down there, you have to multiply by what's called the conjugate. So you multiply by exactly what you see here on the denominator. The difference is, instead of having an addition sign, the conjugate is a subtraction sign. So you would multiply top and bottom by 9 minus root 13. So that's only if you have a plus or a minus in the bottom do you have to do that. If it's anything being multiplied, you just multiply by whatever the radical is. We don't really care about the 5 in the front. So looking at example 1, it says, what are the following quotients? So this first one, we have root 96 divided by root 8. Since they are the same root, just square roots, we can combine them into one square root and see if that helps us simplify. So 96 divided by 8 is 12. So this is now just the square root of 12, which is much easier to simplify. There is a perfect square in 12, so we have to keep going. It's the same thing as the square root of 4 times 3. And the square root of 4 is 2. So we end up with 2 root 3 there. On the second one, it says 5 divided by root 11 minus root 3. So this is one of the ones that we're going to have to multiply by the conjugate because we have a subtraction sign in there. So what I'm going to do is I'm going to multiply the top and bottom. Since this is subtraction, we have to do the opposite. So it's going to be root 11 plus root 3. So in the numerator, if I were to multiply this, essentially you just distribute the 5 to both parts. So in the numerator, we end up with 5 root 11 plus 5 root 3. Now in the denominator, what ends up happening is this is a difference of squares. So if we were to FOIL it, the middle term is going to end up canceling out. So root 11 times root 11 is just 11. And then you'd have plus root 11 root 3 minus root 11 root 3. So then those would cancel each other out. And then last, root 3 times root 3 is just 3. And one is negative and one is positive. So that's why it's a subtraction sign there. Okay. On this next one, we do not have the same root, but we have the same base. So we have the square root of 2 over the cube root of 2. So what you have to do when you see this is rewrite with rational exponents. So the fraction exponent that goes with square root is a half. The fraction exponent that goes with cube root is a third. And remember, when your bases match and you're dividing, you subtract the exponents. So this is the same thing as rewriting with just one base of 2 and then subtracting your exponents. Okay, so we got to get common denominators here. So the least common multiple of 2 and 3 is 6. So first one becomes 3 6. The second one becomes 2 6. So 3 6 minus 2 6 is 1 6, and we have to rewrite it in radical form because that's the way it was. So if 2 to the power of 1 6 is the same as the 6th root of 2. Remember, the denominator tells you what root it is. The numerator tells you the exponent. You don't have to write the imaginary 1 though. Okay, last one. So 2 divided by root 13 plus root 11. So we have that addition sign down there. So I got to multiply by the conjugate. We got to do the opposite though. This one was adding, so I'm going to do subtraction. So here in the numerator, distribute that to both parts. So we end up with 2 root 13 minus 2 root 11. And then in the denominator, what we're going to end up getting is 13 minus 11. So I can simplify this. And on this one, if you notice that these both have a 2 in the front, so if I distribute this divide by 2 to both parts, the 2's cancel, and we just get root 13 minus root 11.